So here we are at TryHackMe's pre-security network fundamentals, packets and frames. Now we're on to task 4, UDP IP. All right. So the user datagram protocol, or UDP, is another protocol that's used to communicate data between devices. We've heard of this. Unlike its brother TCP, UDP is stateless. Is a stateless protocol that doesn't require a constant connection between the two devices for data to be sent. For example, the three-way handshake does not occur, nor is there any synchronization between the two devices. All right. So recall some of the comparisons made about these two protocols in room 3, the OSI model. Namely, UDP is used in situations where applications can tolerate data being lost, such as video streaming or voice chat, right? Or in scenarios where an unstable connection is not the end all. A table comparing the advantages and disadvantages of UDP is located below. We've seen this. The advantage of UDP is faster. UDP leaves the application or the user software to decide if there is any control over how quickly packets are sent. UDP does not reserve a continuous connection on a device as TCP does, right? The disadvantages, though, are UDP doesn't care if the data is received or not. No big deal in 2025, right? But that does make it quite flexible to software developers in this sense, all right? And then also it means that unstable connections result in a terrible experience for the user. But that, with 5G, is not a thing anymore. It's rarely a thing, at least. All right. So as mentioned, no process takes place in setting up a connection between two devices, meaning that there's no regard for whether or not data is received. And there are no safeguards such as those offered by TCP, such as data integrity. No big deal. UDP packets are much simpler than TCP packets and have fewer headers. However, both protocols share some standard headers, which are what is annotated in the table below. Yeah. So the one that's different is going to be this time to live right here. This field sets an expiration timer for the packet, so it doesn't clog up the network if it fails to reach the host or escape. I don't know what that means, but we'll see at some point, I guess. It's got a source address, which is the IP address of the source. The destination was the IP address of the destination. Source port, which is open to the sender to send the UDP packet form, and it's randomly chosen. We already know about that. Destination port, this one's a set port, like 80 for web servers. And then we've got data, which is the header. This header is where the data is sent. All right. So it's pretty much the same except for this one right here, which is kind of different, but no big deal. All right. So next we're going to come on, Next, we're going to discuss how the process of a connection via UDP differs from that of something such as TCP. We can recall that UDP is stateless. All right. No acknowledgement is sent during a connection. Right. So the diagram below shows a normal UDP connection between Alice and Bob. In real life, it would be between two devices. Well, on this one, Bob is going to be us, and Alice is going to be something like Twitch or YouTube or whatever. Right? Let's say it's Twitch. So Bob says, "Hey, give me the stream of our favorite streamer," and they say, "Okay," and that's it. So what does the term UDP stand for? That's not a U. User Datagram Protocol. There we go. Let's submit it. Come on now. User Datagram Protocol. Yeah, that's not how we spell it. Why don't you tell me? Protocol. And submit it. There we go. What kind of connection is this? It's stateless, remember? Submit it. What protocol for transferring files? TCP, we know that. How about for streaming or video call? UDP. Very easy stuff. Hold on. All right. Man, how much is this? Oh, it's not that much. All right. Now we're on to task 5, ports 101 practical, and see you next time.